Today we are going to talk about inverse functions. By the end of this video, you should be able to determine if two functions are inverses, if a function is one-to-one, and you should be able to find the inverse of a function. First, a reminder, inverse functions are functions that undo each other. Couple properties of inverses that you should remember from Algebra 2. F and g are inverses if and only if f of g of x equals g of f of x, which equals x. And the point AB is on the graph of f of x if and only if the point BA is on the graph of f inverse of x. This is the notation that we will be using for inverse functions, and it is read f inverse of x. So our first question is, are a of x and b of x inverses? To determine this, we need to find a of b of x and b of a of x. If they are inverses, then both of these compositions will be equal to x. So first, let's find a of b of x. This means we are plugging b of x into a of x. So we have this composition here. Now to simplify this, we need to find the LCD. So since this is a complex fraction, we want to look at all of the smaller fractions within the big fraction, and our only small fraction is 5 over x. The denominator of that fraction is x, so our least common denominator of all of the small fractions is x. And I'm going to multiply every term by the LCD. This will allow us to cancel out our little denominator and just be left with one fraction. So we have 5x over 5 minus 2x. We can't do anything else to simplify this, and this is not equal to x, so we know that these are not inverses. In general, it's a good idea to check b of a of x as well. If you end up with one of the compositions equaling x and the other one not, go back and check your work because you probably made an algebra mistake. Our next problem is, are j of x and k of x inverses? So again, we need to find the compositions j of k of x and k of j of x. So I'm going to take k of x and plug it in to j of x. Okay. Here's where you need to be careful with your order of operations. You cannot just cancel things willy-nilly. You need to make sure you follow the order of operations. So the first thing we need to look at is the exponent. The cubed and the cube root will cancel out. So we have 2 times x plus 1 over 2 minus 1. Then if we multiply, the 2 and the 2 cancel out. We have x plus 1 minus 1, which equals x. Now we need to double check our other composition. I'm going to plug j of x into k of x. And I plug j of x in. Again, I need to watch my order of operations. First, I can cancel out these 1's. Then if I divide the 2's, those will cancel. So I have cube root of x cubed, which is x. So these two functions are inverses. Let's take a minute to look at the graphs of j of x and k of x that we used in the previous problem. So I've graphed these two here. J of x is the red equation, and k of x is the blue equation. I'm going to make some quick tables here. So if I look at these points that I've highlighted on j of x, I have the point -1, -3, 0, -1, and 1, 1. If I look at the points for k of x, I have the points -3, -1, -1, 0, and 1, 1. So you'll notice here that if I have a point AB on j of x, that becomes BA in k of x, or in other words, the x and the y coordinates switch. If we look graphically, these two functions are symmetric across the line y equals x. Or if you folded the graph on the diagonal, the graphs would line up exactly. These are just a few properties of graphs of inverse functions. Now, not every function has an inverse that is a function. A function must be one-to-one to have an inverse. The official definition for one-to-one is a function for which each element of the range, remember range is the y value, corresponds to exactly one element of the domain. There is an algebraic way to check this, but the method that we are going to use is the horizontal line test. So for a graph to be a function, it must pass the vertical line test. For its inverse to be a function, or for the original function to be one-to-one, it must pass the horizontal line test. So it must pass vertical and horizontal line tests. So let's quickly sketch graphs of these functions to find which ones have inverses that are functions. So first, the graph of x cubed plus 1 looks like this. So if we try to draw a horizontal line through this graph, we will only ever cross the function in one place. We can never make a horizontal line cross this graph more than once, which means this function is one-to-one. So its inverse is a function. We have a look at x squared minus x. This graph looks something like this. If I draw a horizontal line through this graph, I can touch the function in two places, which means this function is not one-to-one. So its inverse is not a function. Lastly, h of x. The graph of negative square root of x looks like this. If I draw horizontal lines through this graph, I will only ever touch the function in one place, which means this one is one-to-one. So its inverse is a function. Now we're going to find the inverse when we are given a function. We have that g of x equals 5 minus 3x over 2. So our steps to find the inverse: first, we need to change g of x to y. Then we need to switch x and y. Then we solve for y. And lastly, we change the notation. So we change y to g inverse of x. So if we take this function, first we need to change g of x to y. Then we need to switch x and y. Now we need to solve. So I'm going to start by multiplying both sides by 2. Then I'm going to subtract 5 from both sides. Then I'm going to divide by both sides by -3. Then, lastly, I need to change my notation. So I have g inverse of x equals, I'm going to rearrange this a little bit, -2x plus 5 over 3. And that is my inverse function. Let's try one more. I have that m of x equals 2x plus 1 over x minus 3. I'm going to start by changing m of x to y. Then I'm going to switch x and y. Then I need to solve for y. So the algebra here is a little bit trickier. First, I'm going to multiply both sides by the denominator. I'm going to distribute the x on the left side. So I have xy minus 3x equals 2y plus 1. Now I want to get all of the y terms on one side and all of the other terms on the other side. Then I'm going to factor out my GCF of y. Then I'm going to divide by x minus 2. Lastly, I need to change my notation. So I have that m inverse of x equals 3x plus 1 over x minus 2. And you can either do compositions to verify that those are inverses, or you can graph them and check to see if they are symmetric across the line y equals x.